but I put up a file right before class, and I will get that right now. I don't know. There's the PDF. I guess the PDF is as good as anything. Not that one. That's the wrong one. So if you didn't get the file and you want to copy it down, close current tab. Oh, wait. There we go. There's the file that I put up today. So go ahead and copy that down. Basic derivative rules. Let me make it a little bit smaller. Why can't I make it smaller? Oh, well. Go ahead and write those down. And I'll move it down after y'all had a minute to write it down. Like I said, I don't know how many of y'all have had a chance to print it out, but I need you to print this out, and I need you to have it by your notes whenever we go over it, okay? Because I do things a little bit different when it comes to derivatives. I don't teach it exactly like they do. I do it a little bit different, and it seems to work okay with students. So I'll give y'all a minute to copy that down. Was any of y'all able to print it out before class?
No, I didn't even notify me that it was available.
Yeah, I didn't give y'all much time. I looked down at the clock and it was already 3:12, and I'm like, dadgum. I just had loaded it, so that's my bad. I suck. Oops. I'm looking to see, did Miss Sterling get back on here? There she is. Glad you could join us, Miss Sterling. I'm going to go fill that in right quick while I'm at it. Well, I'll do it later. Can I move it up now, at least one? There you go. I ordered something new today on Amazon. I ordered a portable whiteboard.
But that was a pretty penny.
Well, it comes in two parts, a projector and a sensor. And I'm going to try it out. So, y'all may be, and I also put in for a new computer for my office, because this office computer is useless with its one port. By the time you use your wireless mouse, you can't even put a projector or anything on it. So anyway, I may be teaching y'all with the whiteboard pretty soon. I know, you're welcome.
You spoil us.
We could go back to primitive ways like some of your other teachers. Let's just go back to email. Y'all just email me your questions and I'll reply and tell you what the answer is.
At least you'd be kind enough to do that. My physics professor doesn't even respond.
That's what gets me. If I did something like that, I'd be called on the carpet. And these other teachers, they just get by with it. Must be nice.
Well, at the end of every email, he says, just email me if you have any questions. Well, I have tons of them. And does he respond? No, not until after the due date.
Yeah, after the due date. Okay, y'all got all those written down? All right. I don't know, y'all ain't gonna talk to me, so I'll go ahead and just go ahead and get started. Now remember, I'm teaching from the aspect of somebody out there really sucks at calculus, okay? I'm not teaching to the person that's already had this class 3 times before, okay? Or somebody that had pre-cal last semester and made 107 in it, okay? I'm teaching to the student that really sucks at it. All right, so the first thing I talk about when I do derivatives is I talk about what's in a term in algebra. Okay, what's in a term? In all of algebra, you have a coefficient and a what? A variable. Okay, now a lot of people say, well, Hubert, there's a lot of instances where there's no coefficient. Well, yeah, there is. It's a 1 because if it was no coefficient, it'd be 0. And then, now, what I want you to do is I want you to remember the basics here. The reason I want you to remember the basics is because when you get confused with these derivatives, if you go back to the basics, then you can work. It's kind of like working a backlash out of a bait casting reel. If you pull enough out, you're able to get the backlash out or the tangle. You're able to get the tangle out. All right. So what the heck am I talking about? Well, give me an algebraic term. Somebody give me an algebraic term. Just a term, not a polynomial, just a term.
2x.
2x. All right. So that is 2x to the first power. All right. Somebody give me another one.
4x cubed.
4x cubed. I'm waiting for somebody to give me one. All right, give me another one.
5x to the negative fifth.
5x to the what?
Negative fifth.
Okay, I want 2 more.
3x to the 1/4.
3x to the 1/4. Okay, y'all not going to bite, so I'm going to go ahead and give you the 2 that I'm waiting for y'all to give me. How about 6? 6x to the what? 0. How about x to the 5th? Now, why am I doing this? Why am I showing y'all this algebra, pre-algebra stuff? The basic law of derivatives is the power rule. The basic law of derivatives is the power rule. If you screw the power rule up, what does that mean about the rest of your calculus, what rest of your derivative laws? You're going to suck at them. So you've got to make sure you understand how to use the power rule. And in order to use the power rule, you've got to remember that every single one of your variables has a what? Has a power. Does everybody understand what I'm showing y'all right here?
Yeah.
And every single one of your terms has a what? A coefficient. So if I tell you, well, give me a variable that has no coefficient, well, then you would write down 0x squared. And how valuable is 0x squared? It's worthless because what does the 0 do to the x squared?
Gets rid of it.
It gets rid of it. So this is the only thing that does not exist in algebra. 0x to the n power. This is the only one that doesn't exist. Now, I want you to remember this, what I showed you right here, as we go into the power rule. Now, the power rule is right there. Well, Hubert, what about the constant rule? Well, let's do the constant rule. Well, let's learn the power rule first, then I'll show you the constant rule. The power rule says this. D dx of anything raised to a power. And what did I just tell y'all here? In algebra, everything has a what? A power. I don't know why OneNote is coming up. Did somebody start OneNote? Okay. It's the Russians.
They're
Oh,
out to
there's-
get through.
I guess I'll get rid of OneNote. Okay, everything has a power. And what you do with the power rule is you take that power and you bring it out front. And it'll be n times x. And then you take that power and you subtract 1 from that power. And that is equal to the derivative. And that's the power rule. Now, a lot of you are going to say, okay, well, that's simple. Wait till I throw some algebra in there, and then y'all run into a tree. Okay? Let's just go.
I think you accidentally muted yourself.
Don't mute me, okay? All right, what is 2x squared? Well, that 2 is going to come out here, and that's going to be 2 times 2, x to the 2 minus 1. And that's going to be 4, x to the first, or 4x. So f prime of x is equal to 4x. Now, how many of y'all have seen a house being built and the footing and the brick being laid? Anybody ever seen that being done before? Well, this right here is your first brick. And how many are we going to lay before the end of the Unit 3 test? Probably about 1,000. You just laid your first brick. All right, so let's do another one. F of x, let's use one of y'all's, 4x to the third. So f prime of x is equal to 3 times 4, x to the 3 minus 1. F prime of x is equal to 12x squared. We just laid another brick. All right, 5x to the negative 5th. F of x is equal to 5x to the 5th, negative 5th, negative 5 times 5, x to the negative 5 minus 1. Oh, some of y'all is going to screw this one up, I tell you. Negative 25, x to the what? Are we done? That's not rhetorical. I'm asking y'all, are we done? That's a yes or no.
Nope. You gotta put
No,
your
not done. Why?
Yeah, put your negative down.
Got to bring the negative. This is all over 1. Bring that negative downstairs. Negative 25 over x to the 6th. Now, I'm glad I did this problem because this is the brick where y'all start to crumble a little bit. Why? Because we're bringing back those algebraic laws that some of y'all suck at. Okay? Now, you're going to see this in the next couple of examples I do, especially when we get to the chain rule. And then some of y'all are really going to, see some of those algebraic rules come about. Okay, so that's why I was trying to get y'all to make a higher grade on the first test rather than the second test. And some of y'all were making 90s on the second test and making 70s and 60s on the first test. Okay, it's supposed to be the other way around. Okay. Well, Hubert, you said you were going to go over the constant rule. Well, I don't have to go over the constant rule if you know the power rule. Let's take the one I did right here. That constant right here. 6. Well, what is 6 got beside it? X to the what? X to the 0, Hubert. And what happens to that x to the -1? So what is the derivative of a constant always?
0.
0. And if you forget, you can always add that x to the 0 and fix it. Well, what is the derivative of, let's see, 2x that y'all gave us? Well, put a 1 right there. 1 times 2, x to the 1 minus 1, 2x to the 0. And what's x to the 0? 1. 2 times 1 is. Do you see why I show y'all this now? I show y'all that everything has a coefficient and a variable with an exponent, so that if you get confused, you can always go back to the basics. As long as you know the power rule. And the power rule says you take the power times the coefficient and then remove 1 from the exponent. Now, of course, we've laid 5 brick out of 1,000, so we need to change it a bit. Well, let's do this one. This ought to discourage some of you. F of x is equal to 3x to the 1/4 power. And of course, what is some of y'all going to do on this one? Come on, you can say it. What are you going to do?
Give up.
Give up. There you go. And why are some of y'all going to give up?
Because there's a fraction.
There's a fraction in the exponent. Not only a fraction in the problem, but a fraction in the exponent. So naturally, out of 30 people, 3 of y'all are going to just not even do it. But you need to follow the power rule. 3 times 1/4 x to the 1/4 minus 1. So now I'm going to go back to my basics because these are fractions and I don't know how to do fractions. 3/1 times 1/4 x to the 1/4 minus 4/4. Now, if you don't know what I did there, then there's problems, okay? We're going to have to talk about it after class, all right? I just made everything into a fraction. So that's going to give you 3 times 1 is 3. 1 times 4 is 4. 1/4 minus 4/4 is negative what? 3/4. And we don't like that, so that's going to come downstairs with 4. So 3 over 4x to the 3/4. Now, as far as writing it with a radical and an exponent, that's up to the directions. I'm not going to worry about that. That's the least of my worries in this unit. Okay? Now, a lot of you are saying, come on, Hubert, this is calculus and you're going over this stuff. Yeah, because I know that there's probably a handful of people in here who have taken calculus at least once or twice. And the reason, 2 reasons. 1, they suck at algebra. Or 2, they didn't get the basics down. Because if you don't get the basics here, you might as well just go ahead and drop after this test. Okay? So let's try another one. F of x is equal to x to the negative 1/2. All right, you try that one. Give you a minute. 5:43. Give you a minute. I'm sorry, 3:43. There's somebody threw down their pencil, so let's go ahead and see if, first of all, that negative 1/2 comes out front. That's a 1 right here. So negative 1/2 times 1, x to the negative 1/2 minus 1. Negative 1/2 times 1/1, x to the negative 1/2 minus 2/2. Negative 1/2 x to the negative 3/2, and that 3/2 this comes downstairs, so negative 1 over 2x to the 3/2 power. Now, I think I just covered at least 3 or 4. Let's see, how many did I cover? I think I covered about 3 or 4. I think I did. Because, 1, 2, 3, 4. I covered 4. No, I didn't. I covered 6. Yeah, 6 or 7, somewhere in there.
Did you take that?
Okay, what comes after terms in algebra? What's after you learn how to do pre-algebra? You learn terms. What happens? What comes after pre-algebra after you learn terms and exponent or coefficient, variable, exponent? What do you do with those terms?
Polynomial.
Put a
I'm
bunch
sorry,
of
I
them
didn't
together.
hear you. I didn't hear you. Somebody said something.
Polynomials.
Polynomials, you put them in a mathematical or algebraic sentence, right? Yes, Hubert. Okay, so that's where you come up with these two. Sum and what? Difference. Sum and difference. F of x is equal to 3x squared plus 2x minus 6. And I want to find the derivative of that function. The sum and difference rule is basically one rule. Basically, if you have a mathematical sentence, you can break it up into f prime of x is equal to d dx of 3x squared plus d dx of 2x minus d dx of 6. If you have a mathematical or algebraic sentence, that means that you can break it up into 3 derivatives. So that's going to give us 2 times 3x to the 2 minus 1. 1 times 2x to the 1 minus 1 minus 0 times 6, x to the 0 minus 1. Now again, I'm writing everything out, so that way it'll be on the recording, That way you can go back and look at it for those of you that have always had problems with calculus. What happens to this term? It goes to what? 0.
6x.
Okay, so you can put a 0 there if you want to, or you can just say, you know, it goes away. I don't care. First one is 6x to the first plus 2x to the 0. And we all know that that x to the 0 is 1. So your final answer is 6x plus 2. And that's using the sum and difference rule. Now, I'm going to ask you for a little bit of, I'm going to go to the conversation piece right now. I want my numbers again. I want my numbers from 1 to 10. So far, what I'm doing, I want to know 1 is still kind of fuzzy. 5, I remember doing it. So far, so good. 10, I invented this stuff. Go ahead, give them to me. Okay. Okay, so we got, mostly everybody's good. I didn't see any 1s, so I'm looking up back over for 1s. Okay, nobody else is going to say anything? Okay. All right, so we need to do something. We need to do something to get y'all down to 1s, okay? Because we got to do something. We can't have y'all knowing how to do this stuff. So let's go over.
Do one with the radical.
That's what I was fixing to do. F of x
There's somebody eating.
is equal to, who's eating? Okay, nobody's going to call. How about x or 4x to the negative 3 plus 2x squared minus the square root 2 or 3 square root of x plus 5. All right, I'll give you a minute to work on that one. I got to get y'all down. I got to humble y'all down a little bit. I got to get y'all down to 1s at least. That's a joke. I don't mean that on, I don't mean that. Miss Sutton, did you get to where you could hear me?
Yes, I can. I can hear you mostly.
Okay, good. Okay, so the first thing I'm going to do is I'm going to rewrite everything. F of x equals 4x to the negative 3 plus 2x second minus 3x to the 1/2. Let's put a note here, and this is a highlighter. Radicals in calculus do not what? Mix. Now, we're talking about basic derivative laws, okay? Not talking about trig. Talking about basic derivative laws. Plus 5x to the first power. Okay? I'm sorry, 5x to the 0 power. Sorry. Okay, now we're going to use the power rule. So f prime of x is equal to negative 3 times 4x to the negative 3 minus 1 plus 2 times 2 x to the 2 minus 1 minus 1/2 times 3 over 1 x to the 1/2 minus 2/2 and 0. That just goes to 0. I'm not going to write it because I'm running out of room. So we're just going to put 0 because 0 times 5 is 0. So now let's clean it up. F prime of x is equal to negative 12 x to the negative 4 plus 4 x to the first minus 3/2 x to the negative 1/2. And now I'm going to clean it up even more. Negative 12 over x to the 4th plus 4x minus 3 over x to the 1/2 or square root of x. Now remember, I told you there may be more simplification, but for right now, I'm just taking it to the first stage of the answer. What could you do? Well, you could find a common denominator of x to the 4th and put everything over x to the 4th, or you could rationalize this square root of x and get 3 square root of x over x. That's not my concern right now. More simplification is not my concern until later. Later means before the test. Then we'll worry about that kind of stuff. All right? Now, one of the reasons a lot of you are saying, well, Hubert, why don't you do square root of x minus 2? Well, we can't do that yet because we haven't learned chain rule. And you can't break up. You could if you wanted to, but I don't think you want chains and whips. I don't think you want to change x minus 3 to the 1/2 to 1/4 and 1/4 or 1. It's just a mess. You don't want to do that. So right now, we're not dealing with radicals until we get to, this is the only radical you're going to have to deal with derivatives until we get to the chain rule. All right? So that is the sum and the difference rule. Now, those three rules, write this down. The power rule, the sum and difference rule, basically they're the same thing. Okay? Because you're doing the power rule, you're just separating it into 3 different things instead of 1. Now, let me give you one that you might see on a standardized test or my test, and you just sit there and stare at it. F of x is equal to x minus 3 times x plus 1. Now, somebody tell me what you need to do here, and staring at it is not an answer.
Multiply it out.
Do the algebra. So I'm going to go out to the side right here. When you're given one that looks like this and you don't know what to do the algebra. Now, they're going to give you some in here that you need to do the algebra first because we don't know how to do the chain rule. I'll show you one in just a second after we do this one. So we got to use our good old FOIL method. F of x is equal to, no coughing in class. You need to lay off them Marlboros. X squared minus 2x plus what? I'm sorry, I did it in my head. Don't do that. X squared plus x minus 3x minus 3. F of x is equal to x squared minus 2x minus 3. And at this point, you can do the sum and difference rule. So f prime of x is equal to 2x minus what? Okay, so there's one right there that you might say, well, I don't know what to do. Well, just remember, the only thing you know to do right now is the power rule, the sum and difference rule. So you've got to make it look like one of those three. Here's another example of one that you might see on a test. Now remember, we don't know the chain rule yet, so we can't address it with the chain rule. For those of you that know what the chain rule is, f of x is equal to x plus 4 quantity squared. Now, if we knew the chain rule, we could use the chain rule here, but we don't. So you've got to use shortcut number 1 and rewrite this as x squared plus 8x plus 16. And f prime of x is equal to 2x plus 8. Question. All right, let's go through it again. How are we doing so far? 1 to 10. On those three rules, 1 to 10, how are we doing? F-O-I-L, that's how you pronounce it. Okay, looks like we got, for those that are participating, looks like we got pretty good numbers. Okay, let's step it up a notch. You cheating. You used chain rule, didn't you? All right, so let's go with f of x is equal to 2x plus 6 times 4x squared. Now, there's two ways to do this problem. Somebody give me one way.
Product rule.
Product rule, okay, because we haven't, well, this was the next thing we got to learn. All right, somebody give me another way to do it. Don't know? Well, y'all just did it in the last problem. What do you do?
Do the algebra.
Do the algebra. Distribute the 4x squared. So we're going to do both. You know why we're going to do both? Because I care about y'all. So we're going to do the algebra first. F of x is equal to 2x plus 6 times 4x squared. So 4x squared times 2x is 8x to the third plus what? Plus 24x to the what? Second. F prime of x is equal to 24x squared plus 48x. Now we should get the same answer over here. And a lot of you are going to say, after I do the product rule over here, you're going to say it's a whole lot easier to do the algebra. Well, I'm giving you a simple problem here. Sometimes you're not going to have a choice. Sometimes you're going to have to do the product rule. So here we go. The product rule, this is where I get a little bit redneck and I go off the beaten path. Okay, this is where I go. I do different. I do different from the book. So when I do this, this is kind of the way I was taught. Dr. Harden taught me. This is how he taught me. F prime of x is equal to the first times the derivative of the second plus the second times the derivative of the first. Oops. That's how I was taught. Of course, he grunted most of the time, but write that down. How many of you have seen this before?
That's how Dr. Bender taught it to me, but what's the other way that's wrong?
There it is, right there. There's the way they want you to learn it. Right here on the screen, product rule. There you go. And see, what happens is students, teachers try to teach you what's on that screen right there, that product rule right there. And once you get about halfway through this, students shut down. They shut down. What the hell are you talking about? But if you do first times the derivative of the second plus the second times the derivative of the first, students hold on to it a little bit better. Because which way do we read?
Left to right.
Unless you're from Middle East, Masalama, you read from left to right. So this is your first term, and this is your second term. So the way I do this is I write it out, and I use some colors. So first, f prime of x is equal to first times the derivative of the second.
Did you do the, did you write d prime on purpose?
Yeah, I just decided to put the denominator in there. That's the quotient rule. The first, yeah, that's supposed to be first. Thank you.
Okay. I was kind of confused by the way you were annotating.
That's all right. You
Thank
just
you.
want to make it look bad. That's all. All right. Plus the second times the derivative of the first. And that's going to be 2x plus 6 prime. So now let's do it. F of x, f prime of x is equal to 2x plus 6. All right, the derivative of 4x squared is 8 what? 8x, Hubert. Thank you, class. So that's going to be 8x plus the second. I don't know why I put that x squared in parentheses. Sorry. 4x squared times the derivative of the first. What's the derivative of 2x plus 6?
2.
Thank you. So now, what are we going to use now? We just did the calculus, so what are we going to do now?
Algebra. Ew.
So let's talk about that. Let's take our orange, highlight it. Here is our calculus of the problem. There's our calculus. So you're done with calculus. So now let's just do algebra. That's going to be 16x squared plus, oh gosh, I hate 8s. 48x.
Yes.
Y'all help me out. Plus 4x squared. Oh, 8x squared. Shoot. 8x squared. And that gives us, look there, 24x squared plus 48x. Now remember, I know you can factor out an x, and I know you can factor out a 24. That's not my concern. If you want to write 3 different ways to write that answer down, that's fine. I don't care. I'm just making sure you can get to this point. All right, 1 to 5. How are we on the right side? If I give you a complicated one, 1 to 5. Everybody gonna be a 7 or above? Let me see. Let me see some. See a couple of 5s. I guarantee you those are people that hadn't been in calculus for a while. So let's do a nerding. Let's step it up a notch. Let's go with, and I'm not going to do the algebra on this one. I don't want you to do the algebra. I want you to do the product rule. F of x is equal to x squared plus 3 times 4x minus 7. All right, do that one. First times the derivative of the second, I'll write it down for you. I'll put it in red. Y'all know I don't like to write in red. It means it's important. Product rule, f prime of x. First times the derivative of the second. Times the derivative of the second plus the second times the derivative of the first. First times the derivative of the second plus the second times the derivative of the first. Hopefully by the time you get out of this Math 140, you will be saying it just like that. First times the derivative of the second plus the second times the derivative of the first.
I've got a really good one for quotient rule that my professor gave me that you might like.
All right, we'll do it on the next one.
All right.
As long as it's not too, I don't want to discourage too many people at one time.
No, it makes it fun, so you'll never forget it.
Oh, okay. So first times the derivative of the second plus the second times the derivative of the first. I'm going to write it down. I'm not going to do anything. I'm just going to put f prime of x is equal to the first times the derivative of the second I put the little prime up there, meaning I got to take the derivative of it, plus the second times the derivative of the first. So I'm going to do the next step while y'all are working. X squared plus 3 and the derivative of 4x minus 7 is 4. Plus 4x minus 7. And what is the derivative of x squared? 2x.
2x.
And now it's all algebra. Because this line right here is representative of your calculus in Math 140. That's your calculus. So you can tell your mom and dad when you go home that that's what you're paying for right there. Paying for that first line right there. So distribute that. F prime of x is equal to 4x squared plus 12 plus 4x. Oops, I'm sorry. 8x minus 4 squared minus 14x. I screwed that up. F prime of x is equal to 12x squared minus 14x plus 12. And somebody check and make sure I didn't mess that up.
Looks good to me.
Well, we could always check it by doing the algebra. And that would be 4x to the third minus 7x squared plus 12x minus 21. And that's going to be 12x squared minus 14x. Look at there. It's a miracle. Now, if you're giving me 5s and 6s and 7s, should you be checking it like this whenever you do a problem like this?
Yeah.
Unless you have LAD disorder. All right, what's the problem you had, Miss Hart?
Oh, I don't have a problem. It's just the way he told us to remember it was low. So like just I don't know, write one for example. It's low D high minus high D low all over low low. It sounds stupid, but you remember it and you know how to write.
Rule.
Yeah, the quotient rule.
Okay, we haven't done the quotient rule yet. Yeah, that's the quotient rule. Yeah.
So you've heard that before?
No, I've never heard it. I had Dr. Harden, and you didn't hear anything else besides him. All right. F of x is equal to square root of x plus 3 times the square root of x minus 6. Now, let me ask you a question. Would you do this one by product rule, or should you do this one by algebra first?
Product rule.
You got one product rule. Nobody's going to say anything else. I would do algebra first. Can anybody tell me why?
Get rid of the radical.
Those radicals are going to
Gets rid of the radical. It gets rid of one of them. You're still going to have one, but it gets rid of one. Okay? F of x is equal to square root of x times square root of x is what? X minus 6 square root of x plus 3 square root of x minus what? 18. And f of x is equal to x minus 3 square root of x minus 18. F of x is equal to x minus 3x to the 1/2 minus 18x to the 0. Now take the derivative. Now the alternative is to change these to x to the 1/2, and you could do that also and do the product rule. But this is an example of why you would do the algebra over the product rule. Is when you see a couple of radicals in there, if you multiply them together, you may be able to get rid of one of the radicals. So the derivative of x, this will be f prime of x is equal to 1 times 1 x to the 1 minus 1. 1/2 times 3, of course, we can't do that. Why? Because it's a fraction. X to the 1/2 minus 2/2 minus 0 times 18 x to the 0 minus 1. Now, hopefully, you'll see that I reverted back to the basics. Why? Because you already got something in there that's going to confuse you, and what is that? That radical. So what should you do? Should you pile anxiety on top of anxiety? Or should you say, well, wait a minute, that's x to the 1/2. And x to the 1/2, I'm going to make everything a fraction. And I'm going to rewrite out everything so I don't get confused. Now, I do realize that some of y'all invented calculus. I understand that. But that ain't who I'm teaching to. F prime of x is equal to 1x to the 0 minus 3/2 x to the negative what? 1/2 minus 0 times blah, 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 which is 0. So that term right there goes out. You just have to deal with these two terms. And f prime of x is equal to 1 minus 3 over 2 square root of x, or x to the 1/2. Again, I'm not really concerned about that. But your answer here is 1 minus 3 over 2 square root of x, or you could say 3 over 2 x to the 1/2. But I would not leave it like this. Usually that's going to be a wrong answer on the homework or the test. Okay, we laid about 10 bricks today. Now I'm going to tell you this, and I mean this in all sincerity. If you choose not to push this homework tonight, this is what, 3.3? If you choose not to go over this homework and you choose to put this homework off until later, then you're going to be lost the next couple of days. Okay? So I would really challenge you. I'm not too concerned about the 3.1 and 3.2. But this 3.3, and I don't know if it's 3.3. Let's look in your handy dandy outline. I have outline. Where's the outline? And of course not. I don't have it. So let me pull it up. Of course, by the time I get to the outline, somebody's going to blurt it out. So let me go ahead and get to it anyway.
3.3 is rules of differentiation.
Okay, that's where it starts. 3.3 is where it starts. I guarantee you somebody's going, oh, there's outline. Whatever. 3.3, rules of differentiation. Oh, I shouldn't even went over 3.1 and 3.2 for y'all. I should have skipped it. All right, so there's the product rule right there. So you're in 3.3 and half of 3.4. So tonight you should be working on, I don't care about, did I give y'all 3.1 and 3.2? Is it in there? Did I give y'all homework on that?
Yes.
Okay, but you should be working on tonight. I don't care about 3.1 and 3.2. You can work on that later. I want you working on 3.3 and the product rule of 3.4, and I want you to send me questions for tomorrow's class. Okay? Question. Okay, right now I'm going to cut off the presentation and stop the recording. And I'm going to leave questions for anybody that wants to stay. If I have counted you here and y'all saw me